And so first, let's talk about call stack. And let me load a program. Oops, let's see, do I have open file, open? So I have this program here, and just not to confuse myself. So we have this program, g equals 1, and it has this increment 2, right? And so I want to know specifically how Python executes code, how it stores variables, how it handles function calls. And I have a copy of all of this over here. In fact, I have it up here. So that's the same program. And I want to look at how Python is going to execute the code. And so initially we have this variable g equals 1. And then we have this function definition called incr2. It takes a single parameter p. And then we have the a equals p plus g, b equals a plus g, return b. And then finally we have this z equals incr2 with parameter 3. This is our method call. And so this is what code is going to do. And I want to see how it's going to run. And specifically, on the right here in these black areas on the right, I have Python's memory. And initially, we're going to store value in Python's memory, that g equals 1. And that g is actually a global. And so that it's going to go in the global. And so this list of globals is things stored at the top level of memory, which are global variables. And so we have this table of all globals. Anything at the top level is a global. So we have this g. And g is a top level variable, and then it's going to store 1. Now remember, things that are not defined inside of a function. So for example, g, if we were to run this code, we could actually get that value of g. Go on this top level, but it's really an object, right? Isn't this really just some kind of object? Python is an object-oriented programming language and stores everything as objects. Well, just to simplify our life, I'm not going to write them as objects. I'm just going to put their values in here directly. Otherwise, I'll be here all day drawing objects for numbers. And so we have this g, which is defined at the top level. It's not inside of a function. And it stores an object to the integer 1, just to make our drawing simpler. And then the code's going to keep going, right? So we can just assume we have this reference to an object, but really we're just going to say 1. And the next thing that's going to happen is we're going to call the incr2 method. Or wait, no, we don't. This actually doesn't call the incr2 method, right? It reads the definition of incr2, and it knows it's defined. It doesn't come down here until the final line. And it says down here, now we're going to call incr2. Now I want to actually call the method. And to handle the call, Python creates something called a stack. And it creates this thing. And a stack is just a portion of memory that stores information about function calls. And we'll talk about why it's called a stack later on. And inside of the stack, we have this function incr2, which is the function we just called. And we get this thing called a stack frame. So this is called a stack frame. So we have this stack frame. The stack frame is just part of Python's memory, where it's going to store values that anything that's defined inside of the function incr2. So its purpose is to track memory, to store memory for the function incr2. And if we look at the function, the first thing in there is actually a p, this parameter. So we need to know the value of p. Well, what's the value of p going to be? Well, we're passing in a 3. So P is going to have a value of 3. Next, we look at the next line here. We have an A. And to figure out the value of A, we look up the value of P, which is 3. And then we look up the value of G, but there's no G in Inker 2. And so it finds the G from globals. And I was going to change my colors, but you know what? I think I'll leave it alone. And so we do 1 for G and 3 for P, and we get 4. So P plus G is 4, and that gets stored in A. Basically, when we look for something, we look for it in the stack frame, the local stack frame. So this is another thing, the way to call this is a local stack frame. We look for G locally. We didn't find it locally, so then we look in the globals, right? If it doesn't find the globals, then we have an error. But it found it, so when we were able to do the math. And then we do the second line B, A plus G. We look up A, it has a value of 4. And then we look up G, and again, it's not in the local stack frame, so we look in the globals, we find a 1. So 1 plus 4 gives us the value of 5. Finally, we have a return statement. And we find that we need to look up B. Well, B is in the local stack frame, we just return the 5. And so this is going to return the 5. So that Inker 2 is going to get returned. It's going to return 5. And once we do the return statement, that local stack frame disappears. It gets deleted from Python's memory. And so it's gone. And then we can go back to that return value, and it said 5. 5 is equal to Z. So there's a Z in here that now has a value of 5. And again, it's at the top frame. Therefore, it's a global. So after executing all this code, we get 5 for Z. We still have 1 for G if we do a lookup. But we don't have P, A, or B anymore. They're gone. They don't exist anymore. That stack frame is completely removed. And that's something that happens when you run. As soon as a function's over, its memory gets deleted. So let's actually run this program. Print out Z, it's 5. Print out G, it's 1. Remember P didn't exist anymore. P only existed inside of Inker 2. Same with B. B only existed inside of Inker 2. A only existed inside of Inker 2. So all of those would actually cause errors because they don't exist anymore. So that's an important part. And so this is actually how your program would run, is it would store the memory line by line. It would look through the value, compute it, and it looks up everything and stores it. And then the stack frame disappears and the function ends. And so every time a function is invoked or called, we get a new frame for holding variables. The parameters that go in the frame with the values copied in. And when a variable name is used within a function, Python always looks for it in the current frame first. There's also always one global frame that all functions can access. And when a variable name is used, Python looks in 2 places. First, it looks in the function invocations frame up here. It looks for it here first. And if it doesn't find it, it looks for it in the global frame. So if it doesn't find it in 1, it moves on to 2. So now we have this concept of being able to look at how memory is defined inside of Java. We have global variables, and then we have the stack frames for all of the function calls.